So today we are going to discuss another portion of the first unit. The topic is significant figures. Now first of all, let us define this. Significant figures are meaningful digits which are known with certainty plus one which is estimated or uncertain. So whenever there is any observation with us, then there will be presence of one uncertain or estimated number also. Okay, so just like here in this example, it is 11.2 ml. Somebody has taken an observation and he found the result 11.2 ml. So here 11, these two digits are certain digits, whereas this digit 2 is uncertain or estimated. So what is the definition of significant figures? Significant figures are meaningful digits which are known with certainty plus one which is estimated or uncertain. Or we can define this in that way also, that significant figures contain all the certain digits plus one doubtful digit. Now when nothing is said about uncertainty, then it is sure that uncertainty would be plus minus 1. Plus minus 1 means it may be increased, the actual value may be more by one number, one digit, or it may be less by one digit. Okay, just like here it is 11.2, so plus minus 1 means the real value or actual value may be 11.3 or it may be 11.1. So that much uncertainty is there. Okay, now let us check the different rules which we are going to apply if we have to report our answer, that how many significant figures are there in any given observation. So there are 5 rules in all. Let us take first one. First rule is all non-zero digits are significant. Means when any observation is given, then whichever number is having non-zero value, that number will be counted as significant figure. Just like here in this observation, it is 285 centimeter. So it means there are 3 digits which are non-zero. So this will be having 3 significant figures. Similarly, this observation 0.25 ml, there are 2 significant figures. Okay. Now second rule is zeros preceding to first non-zero digit are not significant. Such zero indicates the position of decimal point. So in this observation you can see 3 is non-zero digit, but those other zeros which are placed with this they are on the left side. So left side of this, and there is no non-zero digit on that particular side. So it means those zeros are non-significant, whereas only 3 is significant. So in this case 0.03 will have one significant figures. Similarly 0.0052 it will have 2 significant figures. Okay. Now let us come to third rule. Zeros between 2 non-zero digits are significant. Now see here in this observation there are 2 zeros and they are between non-zero digits, so they will also be counted as significant. So in this observation 2.005 there are 4 significant figures. Now fourth rule, zeros at the end or right of a number are significant. Just like we did in the second rule, zeros to the left, they are non-significant if there is no non-zero digit on that side, and similarly zeros at the right or at the end of a number are significant, provided this condition is very much important, provided they are on the right side of the decimal point. Okay, now see in this observation 0.200 gram, 2 is non-zero, and thereafter we have placed 2 zeros. Now these zeros are coming after decimal, there is a decimal already, so it means those zeros will be counted and the number comes out to be 3 in this case. But if otherwise terminal zeros are not significant, if there is no decimal point, this is very important thing to be remembered. Just like see, 100 has only one significant figure. Why? Because zeros are on the right and there is no decimal in between, so there will be only one significant figure. Similarly, if I put like this 100, then I have placed a decimal. Now since decimal is there, so we have to count these zeros as significant figures. So this particular observation will have 3 significant figures. Now check this one. It is 100.0. Now decimal is there, zeros are on the right, so there are 4 significant figures. Now see, for this thing we have discussed earlier scientific notation, n into 10 raised to power n type. Okay, so in that particular form we can write such observations where such zeros are coming. So for 100 we can write 1 into 10 raised to the power 2. This is 1 into 10 raised to the power 2. 1 into 10 raised to the power 2. So in this case, in scientific notation or exponential notation, we have to count this thing only for counting the significant figures. So there is only one significant figure in this case. Okay. Similarly, if we take the same value but we write like this, mathematically it is same, but for counting significant figures there are 2 significant figures. Similarly, this is also mathematically same. Here it is 10 raised to power 2. This is also 10 raised to power 2. So in this case there are 3 significant figures. So it depends on how we are expressing our results. Now the fifth rule, counting the number of objects. For example, 2 balls or 20 eggs. Now see, when there is a definite significant definite number is given when we are counting some objects, then for exact numbers there are some rules. See, if 2 balls are written, then observation is 2. Okay, then observation is 2. Now we can write 2 like this also. We can write 20 like this also, because mathematically it is same. So better thing is to express such things in exponential notation or in scientific notation. Okay, so now if we write in scientific notation, we can say like this. For example, this is 4.01 into 10 raised to the power 2. Now we have to see only this part, so there are 3 significant figures. Okay, now in this observation we have to check only this part, 8.256. So there are 4 significant figures. Now see, whenever some observation is taken, then 2 terms come in our way. One is precision and another is accuracy. So whenever some observer gives his result, then he is told whether his observation is precise or it is accurate or no. So what does these 2 words mean? Precision means closeness of various measurements for the same quantity. Now take for example, somebody is measuring a liquid in a measuring jar and he is saying that he is taking 2 observations. In first he says 11.5. Now this is his first observation. If he says for next observation 11.7, then these 2 are nearby, his results are nearby. So because of closeness of his results, we will say it is precise. It is accurate or no, it depends on what is the actual value, what is the accurate value. In case his results are varying by plus minus 1, then his observation will be termed as accurate. So what is accuracy? Accuracy is the agreement of a particular value to the true value of the result. means whatever is the true value, if by plus minus 1 it is varying, then only it will be termed as accurate value. Now see one example we have taken. Suppose true value for a particular result is 2 gram, and we tell students A, B and C to take observation to 2 observations. Student A takes observation and he says that it is 1.95 gram one time, and another time he says it is 1.93 gram. Now see, there is closeness of results. So because of closeness of result, we will say these values are precise. There is some precision, but they are far away from original value, so they are not accurate. Similarly, B says the values are 1.94 gram and 2.05 gram. Now since there is lot of difference in his observations, so what will be said, that his results are not precise, and since they are far away from accurate value, so they are also inaccurate, they are not accurate. Now say student C, what he gives the results, 2.01 gram and 1.99 gram. Now see, these results are in agreement with definition of significant figures. They vary by plus minus 1 from the actual value, and moreover they are nearby values. So we will say these results are precise also and they are accurate also. Okay. Now one more thing comes, when we have to report our answer up to certain definite number of significant figures, then a process is to be done that is called rounding off. We have to round off our results. Okay. Now how to round off? Suppose the rightmost digit to be removed is more than 5. Rightmost digit means when we are counting our significant figures till our requirement, and then the next number comes out to be more than 6. Just like in this case, suppose we have to form it in such a number where there are 3 significant figures. So what I have to do is I have to stop at 8. So what is the next number? Next number is 6, which is more than 5. So the previous number will be increased by 1. So what we will do? We will convert 8 into 9. So result will be 1.39. Similarly, if the next number is less than 5, then there is no change. Just like in this case, 4.334 we have taken. Suppose we have to give our result in such form where there are only 3 significant figures. So we have to stop here. Now the next number is 4, which is less than 5. So we will make no change. So what will be the result? 4.33. Now it comes for 5. Suppose the next number is 5. Just like in this case, 6.35. We have to round it off for 2 significant figures. Then we have to stop at 3. But the next number is 5. Now since the next number is 5, so we need to check the previous number. The previous number, if it is even, okay, see, if it is an even number, then this will not be changed. But if it is odd number, then it will be increased by 1. Now see, in this case, in 6.35, 3 is odd number. So it will be increased by 1 and our answer will be 6.4. In this case, we have to round it off for 2 significant figures. Then at 2 we have to stop. Now next digit is 5. The previous digit is even number, so it will be unchanged and our result will be 6.2. Okay. Now we have discussed the different rules and rules for rounding off. Now you need to perform these all exercises. So home assignments are for you. Just do it well. Okay, thank you.